Go over the warm-up, plan for the day. Today is 4.7. This is the final section of Chapter 4. Essentially what this section is essentially just a giant conglomeration of all the 6 sections leading up to this point. Essentially, it's going to help you review for your test, which is scheduled for Thursday, because it's just going to have some bigger, badder pictures, some bigger, badder triangles, more triangles in the picture, so it's going to take a little bit more time and thought for you to think about what you need to prove in order to get to the ultimate proof statement, okay? So essentially we're reviewing. The guided questions, we will for sure do the first one in class, but what I'm thinking is the last 3, I'm thinking I'm going to let you work on them at the end of class. I can walk around and check and help as necessary, and if you don't finish them in class, I actually have a video recorded of me doing all the guided questions. So if you don't actually have the time to go over them all together, you can do that there. Homework this evening, 16 questions on Math Excel. All right, you were asked to write a flow proof, blank style. Mark your diagram up as you go. Okay, so what do you start with? The givens, okay? So I know I have been given that segment AC is parallel to segment ED. Okay, let's start off maybe only with that given. I'm going to highlight these. So segment AC is this guy here. I'm going to turn it into a line. Okay, segment ED is right here. Again, I'm going to turn this into a line just for our purposes here. These are our parallel lines. In the last chapter, we talked about parallel lines being cut by a what? Transversal. So I'm going to recognize that this is my transversal. What do we know from the last chapter to be true if we know that these 2 lines are parallel and they're cut by a transversal? We're going to have some congruent angles. So we need to think about in this diagram which angles are going to be congruent because I have parallel lines. So only focus in on my red line and my blue line. So which angles are we seeing? Heidi?
Angle CAE and angle DEB.
Very good. CAE and DEB. What type of angles are those 2 angles? They're corresponding. So that's a piece of information that I get from that fact. I know that angle CAE is going to be congruent to angle DEB. Now let me ask you, what is the official reason? Corresponding angles theorem or postulate. But what I don't want to be seeing is I don't want to be seeing the definition. Okay? All right. Few notes. Parallel does not imply congruence. Okay? I saw that a little bit on your quizzes this chapter. All right, that's not the only given. We have 2 more. We also know that segment CE is parallel to segment BD. So again, maybe it'll be helpful if I highlight those in the diagram here. So I'm going to erase this for just a second. I'll mark my congruencies in just a little bit. So CE is this line here. DB or BD is this line here. These are our parallel lines. And again, they are cut by a transversal. So they are cut by a transversal. What statement, what fact do you know that you can say is true? These 2 parallel lines, so let Heidi carry it. Sorry Heidi, I love you Heidi, but don't carry it. What fact can we bring up that we for sure know is true because these 2 lines are parallel? Very good. AEC and EBD, those 2 angles. What about those 2 angles? They're congruent. Okay? So because of that fact, we know angle AEC is congruent to angle EBD. What kind of angles are they? They're corresponding. So what is the reason I know this is true?
Corresponding angles.
Very good. So you have the corresponding angles theorem. All right, so again, I'm just going to erase these just so that I have it a little bit more clear. We know that angle CAE was congruent to angle DEB. So they're both going to get a single red arc. We know AEC is congruent to EBD, so I'm going to give them both a green double arc. Okay? I'm marking the diagram up as I go. Was there any other given information that might be helpful? Very good. So I'm going to state that E is the midpoint of segment AB. And our reason on that one is just simply given. What does that given mean? What does that given give us about the situation in the diagram? Very good. AE is going to be congruent to EB. So I'm going to bring that up. Because of this fact, I know that segment AE is congruent to segment EB. What is the reason that allows us to draw that conclusion? Very good. The definition of midpoint. The definition of midpoint. Am I done?
No.
Okay. Do I have enough information to draw the conclusion and to prove what I was asked to prove?
Yes.
All right. So this fact, oops, where'd it go? There we go. And this fact allows me to conclude that triangle ACE is congruent to triangle EDB. Now, because I have marked up my diagram, it's helpful for me to understand what postulate or theorem I use. So what postulate or theorem did we use to prove that the triangles are congruent? Very good. Angle, side, angle. Okay? So remember, this was on the front half of the chapter. Okay? This was part of your set of skills that you'll need to have mastered for your test Thursday. Okay? Questions on our proof? Haven't seen corresponding angles in a while, have you? They will reappear for sure next chapter. Okay? Alright, so here we go. I have no definitions for you. I have no theorems for you. I've got nothing else to give you except for examples. Okay? Because like I said today, this section is really just me reviewing for my test. Because the diagrams are about to get bigger and better. So what common angle do triangle ACD and triangle ECB share? So maybe it's helpful for me to maybe highlight the triangles that we're talking about. So we're talking about triangle ACD. So here's this triangle right here, ACD. This is where maybe having highlighters or pens might be helpful. And triangle ECB. So those are my two triangles. And I'm trying to figure out what piece do they have in common, aka what angle do both triangles have in common. So what do they share? Brendan?
Angle BCD.
Angle BCD, otherwise known as simply angle C. I can call this one angle C because it's not any bit confusing. So their common angle is angle C. Why might this be helpful? Why am I even doing an example like this? What are your thoughts as to why I'm doing this type of example today? Besides the fact that it's in the textbook. Brendan?
Well, maybe if you were trying to prove that they're congruent, you could say that angle C is congruent to angle C.
You read my mind, kiddo. If this were a proof, if I was trying to prove that these two triangles were congruent, it'd be helpful for me to see that they both have the same thing. So then in a proof, I could state that angle C is congruent to angle C by what is the reason? The reflexive property. Okay, so that's exactly what our thought is. If you can identify their overlap, you'll have one step essentially embedded in a proof. We would love to see this in a proof. If that was hard for you to see, okay, if it's hard for you to see what the overlap is, what my suggestion might be is to draw out the two triangles, okay? Maybe physically separate them and redraw them yourself if that is helpful for you. Does that make sense? Okay. This might be helpful with bigger, badder triangles to physically separate them out and then label the parts, okay? All right, here's your turn. You have a part A and a part B. You are identifying common pieces, and please note which triangles you are focusing in on in your problems. All right. Are you ready to check to see if you've identified the corresponding piece? All right. So the corresponding pieces that I'm hoping you identified, I'm hoping in A, you recognize that they both shared segment AD. And in B, I'm hoping you recognize that they both shared segment AB. Yay? Questions on it? Okay. All right, so we have 3 more samples, and they're all proofs. Okay, they're kind of leveled for us. So in the first level, we have a couple different things going on. So in these types of problems, it's really helpful to figure out maybe which triangles are being discussed. So when I read this given, I have been given that angle ZXW. So ZXW, this little tiny angle in here, is congruent to angle YWX. So this little angle in here. The other piece I was given are big angles. Angle ZWX, so this entire angle right here, is congruent to the big angle over here, YXW. Those are the 2 pieces of givens. This is what I need to prove. I need to prove that this side right here, ZW, is congruent to this side over here, YX. So let's think to the future. If that's what I'm trying to prove, what is going to be my final reason that allows me to conclude that these 2 sides are congruent to one another? Heidi?
CPCTC.
Exactly. If that's what my proof is, that's me trying to tell you, odds are you're going to have to prove that triangles are congruent in order to conclude that their parts are congruent. So because that's what we're ultimately trying to prove, I now ask the question, which 2 triangles in this picture are we going to want to deal with? And so that's where it's, okay, you have 2 sets of angles. We need to figure out how we can separate the diagram. What are the 2 triangles that you can see maybe in your head without physically separating them that contain those 2 parts? Meredith? Okay, so she said, let me grab my highlighter here. You said Z, Y, X. So this triangle right here, because it's got the big side of green of double arc and the little guy blue. And then what's the other one? Very good. And W, Y, X. So some of us have the ability just to see the picture and pull out which triangles we're focusing in on. Others of us might actually want to physically separate out what the 2 triangles look like. Does that make sense? Okay. We're going to want to prove that these 2 triangles are congruent. I'm just brainstorming my proof right now. Is there a piece of information that you think you might want to bring up that might help us prove that these 2 triangles are congruent? Because I've got 2 angles. I've only been given these 2 angle congruencies. Is there another piece of information I can bring up about these 2 triangles that might be helpful in proving that they're congruent? John?
WX equals itself.
Very good. WX equals itself. John noticed that both of the triangles share that side in common. So once you bring up this common side, you have enough information to conclude that the triangles are congruent. All right, what style do you want me to do it in? 2-column, flow-proof, pair, 2-column? All right, CJ spoke up for the whole group, so therefore we're going to go with it. Because that is the benefit to speaking up to me. All right, what goes first? Givens. Okay, so my given, we know that angle ZXW is congruent to angle YWX. I also know that angle ZWX is congruent to angle YXW. We all know this is given. All right. John brought up a fact that he said might be a good idea to bring up. Because we saw that the two triangles that we separated, what we wanted to prove was that they're congruent. So what's the next fact that I want to bring up in my proof? Yep, WX. What about WX? Very good. We need to bring up that both of those triangles contain the side WX. And we know that WX is going to be congruent to itself. So I'm going to bring up that fact right there. What is our favorite reason? Reflexive property. Okay, so we've got 3 congruencies stated. So we're clearly ready now to state that the triangles are congruent. Okay? So let me be careful. If I call the first triangle ZWX, what is the other triangle's naming if I have to go in corresponding part order? I did ZWX. What are you going to do? Very good. YXW. All right, what allows us to conclude that the triangles are congruent?
Angle side.
Angle, side, angle. Very good. Noticing that they got the 2 angles, and included between those 2 angles is their side. So now that we've proven that their triangles are congruent, what's the fun fact that we know?
ZW is congruent to Y.
Very good. That ZW is going to be congruent to YX. Why is that true? Okay, so CP, CTC. And it was very apparent to me yesterday that not all of us know what CP, CTC stands for. So can someone tell me, what does CP, CTC stand for? Madison.
Corresponding parts of congruent triangles.
Very good. Corresponding parts of congruent triangles are congruent. Okay? And those are clearly corresponding parts. All right, make sense? All right, let's have you work through this one. Okay, we'll do the other 2 on your own individual time, but I think we can handle this one as a class versus individual levels. So you're proving this one. Do it whatever style you want. If you didn't like CJ's 2-column approach, if you want to go for flow, that's fine. You will see for sure at least 1 blank proof on Thursday. And I will tell you what style to do it in. I gave you a lot of given information on this one, didn't I? It's kind of an interesting given. So it looks like some of us need a hint. So let me think about it. If I gave you the fact that 2 triangles are congruent, then what can you bring up? Then what do you know for sure is a true fact? Two triangles are congruent. You know that their sides are congruent. What else do you know is congruent? Their angles are congruent. All their parts are congruent. So are there parts from the first triangle congruency that maybe you're going to want to bring up to hone in on the parts you ultimately want to prove are congruent? Let's talk through this one a little bit more. You're ultimately trying to prove that segment CE is congruent to segment DE. So these two sides are congruent to one another. So what is the hint that you're going to have to use in order to conclude that those two pieces are congruent? I'm trying to get you to prove that those two sides are congruent. What am I hinting to you is going to be my reason? Maybe it's isosceles. Okay, that could be an interesting way to prove this. I'm really just hinting to you to use CPCTC. If I'm trying to get you to prove that segment CE is congruent to segment DE, your last reason is probably going to be CPCTC. But so then I ask you, which two triangles do you want to prove are congruent in order to get the fact that their sides are congruent? Which two triangles might be a good idea to bring up? Very good. ACE or AEC? Yeah. You might want to get to the fact that those two triangles are congruent to figure out that their sides are congruent. Okay, I'm kind of backtracking on this one. So if you're going to try to prove that those two triangles are congruent, were there any parts that maybe those two green triangles shared with the two big triangles ACD and BDC? Okay, so because of this, you already know this fact is true. That segment BD is congruent to segment AC because that given told you that piece. Okay, good. Is there any other fact that maybe the given allows you to make a conclusion about? Parts that maybe those triangles shared in common. Brendan?
Angle AEC is congruent to angle BD.
Okay, so I do agree that these two angles are congruent, but it's not because of the given. What? Hold up. Why are these two interior angles congruent? They're vertical angles. Okay, so then I'm asking you still, what other piece might be a good idea that they share in common? Those green triangles with the big red given triangles. So you got these two little green triangles, and I'm asking you, what do they have in common with the big triangles that maybe would be a good idea to bring up? Meredith? Very good. She's recognizing that those big red triangle givens have those angles in common, okay? So those two facts, the side and this angle that Meredith just brought up, we know those are true because the given told me the triangles were congruent, and we know by CPCTC that they are congruent. And then those other angles, those were vertical angles. After I brought up those facts, the two green triangles are congruent by what? Angle, angle, side. And then once I prove that the green triangles are congruent, then what do we know?
That CE is congruent to DE.
Exactly, that CE is congruent to DE. So what you needed to recognize is the fact that because I gave you congruent triangles, you need to think about what parts from those big triangles do I now know are congruent that are maybe shared inside of those smaller triangles, okay? Because then once you prove that those smaller triangles are congruent, then you know by CPCTC that their parts are congruent. So my observation on this got it. Notice in this situation it was helpful to have two sets of congruent triangles. That's actually where this is going to be taken next, in the next two examples. But Heidi actually brought up a fact that I've never thought about on this problem, so I want to go back to it for just a half second here, Heidi. So Heidi brought up the fact that, so here's my little picture here. If you know that those two triangles are congruent, then you know that this angle is congruent to this angle, right? All you need to do after stating that those two angles are congruent, we know that those two pieces are congruent by the converse of the isosceles triangle theorem. So Heidi's proof actually takes 3 steps. The other proof took a little bit more. So nice job, Heidi, on that thought. Okay? All right, the next two we're going to go over together, but we're going to save your time at the end for your guidance. Okay? Because this is now the big scary images. Okay? Where all of a sudden, I'm seeing a lot of different triangles. And now the challenge is, what triangles do we want to use? So when I see this design, how many different triangles do you see?
4.
I see more than 4. I see 6. I see 6 different triangles, which means potentially 3 different sets of congruent triangles. So then the job is, all right, which ones are going to be most helpful? Okay. So I'm going to zoom in on a white image. That way it's not all red and easier to see. So in the given, I have been given that E is the midpoint of both AC and DB. We'll interpret that in a second. I'm hoping all of you recognize what that means. Ultimately, what I want to prove is that triangle GED is congruent to triangle JAEB. So that's ultimately what I'm trying to get to. That is the goal. Okay? So now let's look at the given and see what we could do with the given to maybe get into those triangles. What style do you want to do this in? Flow. Oh, now people are speaking up. All right, so we know E is the midpoint of, I'll write both in one spot, segment AC and segment DB. What's our reason on that one? Given. Okay, I'm going to move this up a little bit. All right. What does that mean? Heidi talks a lot in this class. Madison. So that's one piece we for sure know. We know that DE is congruent to EB. So I'm going to write that out. I know that segment DE is congruent to segment EB. What is our reasoning on that one? Definition of midpoint. Okay. Any other piece you know? We know that AE is congruent to EC. Okay, technically, could I put these both in one statement? Absolutely. So I know that segment AE is congruent to segment EC. Definition of midpoint. Okay. We ultimately want to get to triangle GED and triangle JEB. How many congruencies do I have about those two triangles so far? Just one set. Internally, could we see another one that we could for sure add?
Yeah.
Okay, but we're not there yet. We can't do it. So we can't jump into the fact that those two triangles are congruent. So then I'm asking you, is there another set of congruencies between triangles that maybe you could bring up in order to use the fact that their parts are congruent? So your vertical angles that Madison's bringing up, I'm going to bring those up later because those are going to be necessary to prove that those triangles are congruent, right? But those aren't the ones that I'm going to want to bring up. Notice I've got two pairs of congruent segments. I only need one more piece of information to prove that two triangles in this picture are congruent. Which two triangles am I thinking of when I see this diagram? Heidi.
A, B, congruent to B, C.
Yeah, we want to bring up these two triangles. Because if we bring up these big triangles here, we can get to some other parts. Okay? How can I prove that these two big triangles are congruent to one another? What other information do you need to prove that the big red triangles are congruent? Okay, so maybe AD is congruent to BC, but is there any given information that lets me conclude that? What information can you add because you have the ability to see this in a diagram? You've had this ability since chapter 2. What information can you add because you know that it's true about these two red triangles? The vertical angles. I need you to recognize that you can still bring up vertical angles. So I know that these two big red triangles are going to be congruent. Okay? So what is the name of these big vertical angles? Very good. AED. So I'm going to say angle AED is congruent to angle BEC. That's using the vertical angles theorem. So now, because of this piece, and this piece, I can say that these big triangles are congruent. Okay? So triangle, if I call a triangle AED, what do I have to call the other one? If I go AED, I gotta go
CED.
has to be CED. Has to be corresponding parts. Because AE is a double, CE is a double. What allows me to conclude that these triangles are congruent again? Very good. Side angle, side. So now that I've proven that these two triangles are congruent, I'm hoping you know that their parts are congruent. So let's remember the triangles we're ultimately trying to prove are congruent. Ultimately, I want to get to this triangle and this triangle. So are there any parts that those two smaller triangles have in common with the two bigger triangles that we just proved to be congruent to one another? CJ?
DE and EB are congruent.
Well, we already know that fact, so we already have this piece. Okay? But is there any information from the fact that we know that these triangles are congruent, the big triangles, that may be helpful? Are there any overlapping parts that the big triangles have in common with the smaller triangles?
GD and BJ.
No, because that's only part of their sides. So you need to remember that we're talking about this big triangle. Where does it overlap with the smaller triangle? What piece do they have in common?
EC.
We don't have AC in common because you see there's only
EC.
red.
EC.
Well, they don't have that in common either. What does this big red have in common with the little blue? Caroline?
E.
I agree that they have the midpoint in common.
ED.
Why are you focusing only on sides? What?
Angle D.
Angle D. You need to recognize they both have this angle in common. And if you bring up that angle in common, you're almost done to proving that the blue triangles are congruent. So because we know that these triangles are congruent, we know angle D is going to be congruent to what angle from the other diagram? Uh-oh. D doesn't match up with E. B. We know that their corresponding parts are congruent. We know CP, CTC. So we now have that corresponding part from the big triangles down to the little baby blues. Okay. You have an angle and a side. Madison tried to bring something else up earlier that may have some good timing now. The vertical angles. What vertical angles did Madison want to bring up earlier? Yeah. Very good. Those two inside right there. Okay? So we need to bring up the fact that angle DEJ is congruent to angle JEB. Why was that true? Very good. All right, so now, it's going to be a really ugly flow proof. I don't know who, but this is a terrible one. How can I conclude that the two baby triangles are congruent? That GED is congruent to JEB. I've got all my congruency markings in there. What do I use to prove that those triangles are congruent? I'm not using side, angle, side. Angle, side, angle. Angle, side, angle, angle, side, angle. So it's because of this angle, and this side that we used from the beginning to prove that the baby triangles, GED, is congruent to triangle JEB. These problems are not easy. Okay, there's a reason it's last. Because the reason they're hard is that you have to try to figure out, are there overlapping parts that might be helpful to bring up to prove the ultimate proof. Okay? So when I was trying to explain that to you, I was looking at the red triangles and seeing, does it overlap with the baby blues at any point? Does that make sense? All right, you're going to do this got it for this problem at the end, because I want to get through the next example. Okay? So I've already kind of separated these guys for you, okay? Drawing them apart, but once again, the thing you got to overcome in these pictures is the fact that there's a lot of triangles happening, okay? So ultimately, I'm trying to get to the fact that segment BX is congruent to segment DX. I want this piece to be congruent to this piece. So ultimately, it might be helpful for you to figure out, okay, those two sides are both part of which two triangles?
BAE and BEA.
I don't want to do BAE because it's not a whole side. BAX. I'm noticing that it's part of triangle BAX and triangle DEX. So because those two sides are part of those two triangles, it might be a good idea at some point to prove that those two triangles are congruent. But will I have enough information? That is the big question, okay? So let's look at the given. We know that segment CA is congruent to segment CE. Does that have anything to do with those little baby triangles that we just talked about? Nope, nothing. We also know that segment BA is congruent to segment DE. Does it? Yeah, that one does. All right, so I'm going to mark those over here. Maybe I'll mark them over here as well. Is there any congruencies that I know I'll be able to add into this picture eventually? The vertical angles, very good. But is two congruencies enough? No. So that's where it might be helpful to think about other triangles that we could prove to be congruent, because we're not ready for this one yet. Okay? So the other two pairs of triangles that I see are triangle Bay and Day. Triangle Bay, triangle Bay. So let's talk about those again. We already know this fact is true. The segment BA is congruent to segment DE. Okay. What else about those two triangles do we know to be true?
They share AE.
Very good. They share AE. So we know we're going to bring up that fact at some point. Okay? Might be a good idea at some point in our proof. So I'm going to look at that given one more time. Have I even started writing my proof yet? Not yet. We know this fact. Segment CA, this entire side, is congruent to the entire side of CE. This piece of information right here has a whole lot of helpfulness. If I know that those two sides are congruent, then what else can I bring up? Very good. I'm going to bring up these two base angles here that are congruent to one another. Why do I know that those two angles would be congruent to one another? Very good. The converse of the isosceles triangle theorem. Notice those two angles are those two angles inside those baby triangles. Okay, it's kind of like this is baby bear, mama bear, papa bear. Do I have enough to prove that mama bear is congruent? According to my little sketch here? By what? Very good. So let's go forth and take care of this. What style?
To column.
Because this is going to get a little bit messy if you try to do this as a flow. So we're going to do 2 column here. Okay? So statement, reason. I'm going to start off with my
Given.
big surprise, I know. You will notice those are starting to not be easy points on your tests anymore. I'm starting to start to fill those in for you. All right, so we have all of our given facts. Okay. What other facts did you and I verbally discuss that might be a good idea to bring up?
A is congruent to E.
Okay, we're going to bring up AE is congruent to AE. Very good. So we want to talk about AE being congruent to AE. Why is that true? Very good, reflexive property. Okay, we brought up some other facts. What other facts did we bring up? CJ?
Angle A is congruent to angle E.
Very good, but I'm not going to call them angle A and angle E
Oh.
because that's going to make me lose some points. But those base angles are going to be congruent by the converse of the isosceles triangle theorem. So converse, isos, triangle theorem. Proper naming. Angle B is congruent to angle DEA. Okay? We label those pieces that got separated. And so then you told me that we know that those 2 triangles are going to be congruent. We know that triangle B is going to be congruent to triangle. If I call it B, what do I got to call the other one? This one's B. This one's going to be, very good, DEA. What says that those 2 triangles are congruent? Very good, side angle side. So just like the last example, it was helpful for us to bring up the fact that 2 triangles were congruent to one another. Okay? So now I'm trying to think about how can I use that now? Because I want to take the congruencies from this mama bear into the baby bear. Okay? You already told me we got vertical angles in baby bear, right? We all agree to bring that up next? Okay. So we're going to bring up the fact that angle BXA is congruent to angle DXE by the vertical angles theorem. But this is where I got you guys last example. What part do these 2 triangles have in common with these 2 triangles here? What do they share in common? This is one of the most difficult parts of teaching. I can't teach you how to see. There's something that this triangle and this little baby triangle have in common. Charlotte?
Angle B and angle D.
Very good. It's that angle B and that angle D. But I'm not going to call them that. But I know that these 2 angles are congruent, which will carry over into these little 2 angles in here. Because they're congruent in the first set, they're going to be congruent in the second set. So I'm going to say that. I'm going to say angle ABE is congruent to angle EDA. CPCTC, they're congruent in the first set. They're corresponding. They're going to be congruent here. Do I have enough information now to conclude that the baby triangles are congruent to one another? I hope you say yes.
Yeah.
So we get ABX triangle is congruent to triangle EDX. What did I use to conclude that? Angle, angle, side is right. Was that what I was trying to prove this whole time? Okay, the whole time I was trying to prove that BX was congruent to DX. So what's my last reason? It's a favorite one now. CPCTC. There's a lot of layers to these problems and they take a lot of practice. Alright, so you're going to need to complete those 2 got it's. You can check your answers in the notes. I also have the video recorded if you need assistance. Otherwise, there's only 16 Math Excel problems this evening. Okay? Look.
Is there gonna be one on the test like that?
Like one overlapping?
Or yeah.
There will be at least one overlapping. Because these are they're tricky ones, right?
Yeah.
Yeah, they're real tricky. I'm not going to lie. I understand. I'm going to say 1. Because ultimately, I just want to make sure you guys know how to prove triangles are congruent. That's my ultimate concern. And quite frankly, I know if you guys were